this lesson, our objective is to be able to solve exponential equations. The difference for this video is that we're going to use exponents that are higher than just squaring and then taking the square root. So let's first of all talk about our steps for this. Our first step is to isolate. We want to get the variable term by itself. And then second, you want to raise to the reciprocal power. In other words, raising to the reciprocal power is the same as taking the root. So I'm going to put here in parentheses, take the root of both sides, because most of the time people will just go straight to taking the root rather than the reciprocal power, but you'll see us at times using a variation of those. A reminder when you do this and you solve the equation, your result when you have an even exponent will include a plus or minus. That's because when you take the square root or the fourth root or the sixth root of an even power, you get an absolute value on that variable, which produces a plus or minus. But what you need to remember is that if you have an even exponent for this, then you use a plus or minus. But when you do not have, when you have an odd exponent, that means there's going to be no plus or minus. So remember to add that plus or minus in when you have an even exponent, because you'll get two answers for the result. So let's take a look at a couple examples. Let's do 3. I'm going to do 2x squared equals 72. Let's solve this. So isolate the x term first. So let's divide both sides by 2. Dividing by 2 gives you x squared equals 36. Now the next step, you have a variety. You can either do the square root of x squared equals the square root of 36, or the other way to do it is x squared to the 1/2 power equals 36 to the 1/2 power. Now this is doable on your calculator. You can raise it to a fractional exponent. Most people will go straight to doing it with the root. And when you do that, either one of them, you get the absolute value of x equals just 6 when you take the square root of 36. But then we typically skip straight to the step of just saying that produces a plus or minus 6 for our answer. So you can cut down on the steps by going to the root and then skipping the absolute value. Just remember to put the plus or minus on your answer. So let's do a second example. This one's going to have an odd exponent. So 4x to the 5th equals 128. Now when we do this one, we want to take and get the x to the 5th by itself. So divide both sides by 4. You get x to the 5th equals 32. Now this one, you want to take the 5th root of both sides. Again, it's either the 5th root of x to the 5th equals the 5th root of 32. Now on your calculator, that's not as doable. That's not the 5th root. You can find a 5th root on your calculator, but it's not as quick. It takes several layers to get to that step. So sometimes on this type of problem, people would do it this way instead. Use x to the 5th to the 1/5 power equals 32 to the 1/5 power to do that problem. Now because this is an odd exponent, there's not going to be a plus or minus to it. Now what we do is we pull up our calculator on this, unless you already know what the 5th root of 32 is, and what you'll do is on your calculator, you'll type in 32, and then raise it to an exponent, and then on the exponent, I'm going to put it in parentheses, though since it raised it up I don't need to, but I'm going to put it in parentheses, 1 divided by 5 as my exponent, and I get a result of just 2. 2 to the 5th equals 32. So I get as an answer just x equals 2, no plus or minus, because it's an odd exponent for it. All right, let's do one more. We're going to do another odd problem, and on this this one again, we're gonna use our calculator, but we're getting 2 decimal places. These were exact answers that we just did. This next one won't have an exact answer. We're going to round it to 2 decimal places. So we're gonna have 3x to the third equals 10,002. First step is to get the x to the third power by itself, so divide both sides by 3. If you divide that by 3, you'll get 3,334. Now I've got to take, again, for this one, there is a cube root button on your calculator in some of the menus, but what I'm going to do is just use instead the fractional exponent as a reciprocal. That will get rid of it because 3 times 1/3 is just x to the first. It's odd exponent, so we'll only get one answer, no plus or minus. But I need to do this 3,334 to the 1/3 power on my calculator. So let's enter in 3,334 and raise it to in this case, I'm gonna have the 1/3 power, 1 divided by 3, and I get as an answer 14.939, etc. Notice it's a decimal, it's rounded because it's an irrational number. I'm gonna round it to 2 decimal places, so it'll be 14.94 when I do that. 14.94 for my answer here. That's what it's approximately equal to. So the steps we use for this are to get the variable term by itself and either use the root or the reciprocal power to get the variable by itself. If it's an odd exponential problem, then you only get the single answer. But if it's an even exponent when you're starting the problem, then remember to put your plus or minus for your answer.